Hey everybody, I don't think there's anybody out here yet. So what we're doing here is haven't done much with this transformer. I actually haven't done anything with it yet. Just check and see how easy it is to make it resonate. This one's grid input coming in 60 hertz, 120 volts. And, over here is output current, input, output. Ultimately, we'll go into this heat sink heating element. The heat sink just a nice resistive load, maybe a little on the inductive side. Well, 10 amps on this side. And barely anything registering on the input. Okay, so I'm looking 32 volts output. Alright, so I'm going to use these yellow leads for resistive load. Yeah, right here. So that's that. 10 amps. 9.8, almost 10 amps. Going into the load. Still really anything registering on the amp. It's probably about 200 or 300 milliamps. I'll have to get a digital gauge. Where is it? Temperature isn't rising at all. We're still 93 degrees. Oh. Yeah, 92, 93. So we're driving this coil. We have a capacitor across the coil on this one, which I'm going to lift off. And our output decreases big time. So this is AC cap is 60, 32 UF. I think this, and this is 60 UF. Yeah, so these two capacitors are on the 100 volt tap. Other than that, the 100 volt tap is just going to these two capacitors, which we added up to what, 92, I believe. And that's it. We're not taking any power from there. And this one over here is pretty much running without any capacitors on it at this point, but we're going to be changing that in a second. So we've got still almost 10 amps. We're going to take the 7.5 UF and this green one, which is the other side. So what I've got on this is a 110 volt, 100 volt winding, and a 120 volt winding in series to equal 220 volts. So we're putting 120 in. I don't even, it's crazy with this transformer, because let's see what happens when I change the resonance on the middle core. Hey, we got 2 people watching. Yay. Thanks for stopping by. Doing some quick testing on this particular transformer. It's a 3-phase transformer. And the part number is actually manufactured from Schindler Elevator Group Corporation. The part number is 222981. 50-60 hertz. capable of probably like 12 or 1400 watts, getting almost 10 amps at 108 volts under load. I'll have to measure the impedance of this, but what this is a I believe it's a 5,000 or 6,000 watt heater coil that potentially has either 220 volt taps or series it up for 240 volts. It's getting a little long. Still no change in temperature, 92 degrees. It's the same as air temperature right now. It's hot as fuck in Texas. Excuse my French. Yeah. No heat being generated on either side. If you watch on your mobile phone, you can probably pinch the screen off and should be able to see these. Yeah, don't bother. I just tried it on my phone because I'm monitoring on my phone. I can't see these, so. Using the web camera up there where you're looking down from. I really don't want to pull it down. So you're going to have to take my word for it. So we've got roughly a little over, it's just, I mean, this is just barely, take that, it's about 100 milliamps, maybe a little over 100 mils and 120 volts. Actually, accurate voltage from coming from the grid here is, I think it's 127. So you guys are going to do the math. And coming out was still 9.5 amps, almost 10. So it's like barely touching the 10 amp bar on the scale. So it's very strong 9 amps coming out. Right now we're 153. And if one of these caps are getting long, something's changed just a little. We were 160. Now the caps aren't long. That's serious overunity right there, guys. You gotta find a scrapyard around you. There are some kind of electrical supply, or maybe you go on eBay, or I bought some nice transformers off of eBay. They're fairly cheap money, reasonable money, a couple $100. I mean, you can use something like this. You get a solar panel with a grid tie inverter. Power this from the solar panel. A lot of the new solar panels now, they have all independent inverters, and they all combine together. The whole array will. But you can take the output and drive one of these setups, and then your output's a lot multiplied. So for one panel, you're probably going to end up with maybe 3 in output over here on this side. And it's a nice multiplier. Not violating any rules. I know this is that's nothing. No heat. Nothing being generated. Yeah, so I don't know if the winding ratio compared to the core size, I'm going to have to investigate why this is a little unique. And really, I think I'll have to try the other ones. So I think I can I can't do a snapshot, but that's just in a few minutes, just messing around with a few caps, not even bringing this cap substitute box out. And trying to resonate it. It looks like it's resonated pretty good. So this is 1.5 UF. I just want to see if this does for me. It's actually a high voltage microwave oven capacitor. So I'm sure there's a bleed resistor in there. I just want to add a little more capacitance to a little more. It's like 6 volts. So 1.05. .75. Let's see what this does. If the peak goes up, let's see which side the peak we're at. Oh yeah, okay. So that's even a bigger increase than this. So we're probably pretty close to the top. These wires are getting warm as hell. Yeah, 140 degrees on the wire. It's actually starting to wrinkle up a little. So that's just the current we're drawing through the load over here. Still the same temperature, 93 degrees. 93 all the way around. The core is. The capacitors are getting warm and all. And the load bank is, oh, it's hot. Almost 400, 380. 380. Yeah, 380 degrees. So it feels like it. So 120 volts in. And I'm just going to call it 200 milliamps, but I think it's a little less than that. And coming in, which I'm going to have to set up the other scope probe in and use a 1 ohm resistor. And curious to see what my phase shift is on this. It's got to be pretty close to 90. Or maybe a little lower, who knows. Yeah, I've never seen a three-phase transformer where you add capacitance to the unused core in the middle and you're running it single-ended. I've never seen the capacitor add that much output. But I would imagine if I don't do anything with the middle, which I'll probably do, is rearrange my windings and see if I can't get all that back. It might be just an impedance ratio between pole B and pole C, you know. But don't forget, there's a three-phase transformer. So you got to think of your phases and degrees times 3. What's going on, guys? I see 3 people watching. No speaky, huh? Still drawing 10 amps. Oh, gonna have to let that. I'm gonna have to put something else in here. Holy shit, that's hot. Whew. So next time I get some, I gotta get some that are only a foot long. Sometimes the 20-something inch clip leads are just a little too much. Just ends up being like a wiry mess. Here we go, back to the load. Yeah. So it's all I've had these sit on 15 amps without a problem. So heating element load is still low. Actually, it's a little higher now. It's almost touching 490. What is that in Celsius? Yeah, 491 in some places. So that's hot. 93 on the coils. 93 cores. I'm still 93 degrees, the same as their temperature right now. No long capacitors. Yeah, that's just like, that's barely. That's like 1/3 of the way to 500 milliamps. Actually, it's not even that. Let it go. Back. It just barely moves. I don't know if you can see this. If you happen to watch at this moment, try to pinch the screen off now. Might be, have to wait for the sunlight. I've got this thing set up, the camera set up for streaming and lower lighting. So the garage door is open a little and everything's a little bright. I went live earlier today and it was too bright. I didn't want to go in there and change the settings because it's more apt to use it later in the day. And the reason why is the sun just blows right in on its way to sunset. It's just blowing right into the garage door. I don't even have the garage door open. Not even halfway open. Just a little light in. Yeah, look at how this crinkled up all this wire. It's cold now. But it was starting to sizzle. Supposed to show you how much current's being drawn from that. Serious over Unity right here. Not relying on any magnets. Nothing to wear down. If you don't abuse it and you keep it within normal operation, you get a lifetime out of that. Yep. Yeah, so 127 volts right now coming from the grid. Yeah, just a teeny bit under 200 milliamps. And then coming out, we're at 166 volts AC. And we have almost 10 amps under load. Nothing's changed. No hot caps. Ooh. Yeah, 490. With a glow, it's starting to glow red. Yeah, let's see it. Just a fly on the wall. Yeah, it's okay. Sorry, I didn't catch the chat. What was that? Oh, that was a while ago. You might not even be. No, you might still be here. Somebody gave me a thumbs up. Appreciate that. Yeah, so listen, you don't have to get this exact same transformer. Any step down transformer that is usually a 208 volt range for the low end, all the way to 480 for your primary winding, and then your secondary winding. Like this particular one has only on each coil A, B, and C 100 volt winding. And that's the difference, because if I didn't have that 100 volt winding to add with over here, because I've got the 100 volt on the input, I've got the 100 volt and two of the 220 volt inputs on this coil. They're all seriesed up, so it's really inductive coming in, really reactive. inductive. And we've got a 92 UFs worth of caps on pole C. Pole B. But we're not taking any power from it. We're just paddling the output coil of the 100-volt winding with the cap. I may decide in a few minutes, if you're going to hang out, it might be worth it to watch this, because what I'm going to do is we'll start adding jumpers and see how much voltage I can come up with, because don't forget, your back EMF is going in B right now from the draw. So I'm either going to be able to it'll either help or hinder my output. Will either go up more or go down. I'm curious to see what that does. And then also we can do a short circuit. Now when I short B out all the way, my output goes to 11.5, almost 12 amps right now. And yeah, so my volts across, which I'm scoping across the load, that is 173. 173 just went back down to 160, 159. So that's interesting. Don't forget, I got no shunt bars on this, top or bottom. It's just a stock 3-phase transformer. When I short B out, you can hear that spark. It's a pretty decent amount of current. And it is getting hot. 130 degrees. But my input increases to almost 500 mils. So that's not bad, considering we're still getting the 10 out over here on the output side. So it's not, this can be duplicated by anybody. There's nothing fancy about the transformer. I just gave you the specs on that. 92 UF on the middle, and if you want, I would imagine if you took 2 diodes, the cathode, and maybe with a Zener, maybe a 20-volt Zener on each one, and then have that tied to a rheostat, maybe 100 ohms, no, maybe 300 ohms, 0 to 300 ohms, which I've got. So I'm going to use this one and dial in and see what I can get. If I can't tune, I want to be able to tune the shunt bar, because that's what it's being used for. We just happen to have a coil around the shunt bar. On coil B, it's got a coil right around it, right? So we can manipulate things a little while still resonating. And right now I've got, let's see, yeah, 20 UF and 0.75. So these are in parallel, tied into both sides of the outputs of the 100-volt tap and the 220 volt tap. So we got some real power coming out of here. Not much coming in. I got to dig up my old school power meter. I'm curious to see if I'm stopping the meter, or actually I got one of those electronic ones. I should check my power factor on that. Yeah, so if you guys stick around, I'm going to be going to the refrigerator and probably getting a couple of snacks, haven't had a beer yet, so I'm kind of like want to get that out of the way. So help yourself. You guys want to hang out and watch what I'm doing. I'll try to be as redundant as possible in case somebody skips along and they don't want to watch the whole live, because it's going to be a long video if you go back and watch it later. Yeah, with some time to kill, so I'm going to do this. I've got other projects going on in here at the same time. I need to set up another workbench. I think I'm going to build a 4x8 or maybe 4x7. Yeah, and then probably set it up with drawers underneath and a little storage. Yeah, this one here has got, that's a big deal, but you can see the drawer. I just pulled it out. There we go. Hope it didn't make anybody dizzy. Okay, we're still drawing 10 amps. 92. Temperature's going down. What do we got here in the tail? Yeah, 92. So it's starting to cool off a little. Not the transformer, just the air temperature in general. The sun's actually starting to go down. So no increase in heat anywhere. Capacitors aren't warm, same as air temperature. That's getting a little warm there. Yeah, 492, 492 degrees. Got a nice glow on it. I don't know if you can see that when you're, maybe not. I bet you that camera that you're looking through has probably got a filter on it. It shows a little on my camera on my phone. It's got a glow. Yeah, Doug, if you happen to catch this, kind of interesting what you're doing over there. Don't stop, man. Keep going with it. Gotta loop them things. Yeah, nothing's changed. $92. Plenty of heat coming off of the load. Yeah, so these two capacitors, which equals 92 UF, are just connected to the 100-volt winding on Coil B. And 20.75 UF resonating Coil C. both the 100-volt winding and the 220-volt winding to get me 160. It bounces, but consistently right around 160 volts. There must be a little ferrule activity going on in there because the voltage. I know the scope. I mean, the Handtech scopes. It's a 200 megahertz one, and it's not bad. I mean, they're cheap China stuff, but it's still decent enough. I would prefer to use those than I've got a bunch of old Tektronix ones that which are great though. They use once in a while, maybe for the nostalgic side of things, but a lot more information. So this is not a plug for Handtech. I just happen to like what they do. So, and I like I've taken not this one, but I've got another one just like that. I've opened the back up and looked inside, and I think I didn't see anything in there I didn't like. I looked for heat dissipation to make sure that was taken care of, and did a good enough job with it. I didn't improve or modify anything. As a matter of fact, I didn't even bother even doing the updates to them. I've got the original operating system in there, whatever build that is, because they work perfect. They do what I want. I don't want to reflash and then start finding bugs and go with a scope that was working very nice to having problems. So I have downloaded all the Handtech stuff, all their drivers, everything, just in case something ever happens to them, which I hope nothing does. They're always coming out with some great equipment. So 59. I'm watching the frequency on the scope. It's bouncing just a little on us, like 50 and 91. Everybody's ACs must be kicking in. Or maybe everybody's electric cars are getting plugged in right now. It's always interesting to know the power that you get at your house, your apartment, or wherever you live. You never hear the generator, but if you had a generator running, you'd hear the load changing and the RPM, which would control the frequency. And so the only reference you got to the power plant is the frequency change. Consistent. Seven. We're getting a little heat. It took a while. 105 down there, 107. So we're getting warm. .96 on the input coil. 96 on the coil B. Coil C is 108. Yeah, you can feel it. I don't know how long we've been on live, so it's probably a half hour maybe. So that's not bad if it doesn't change or it goes any higher than that. Hey, buddy. I'm sorry. I gotta pay better attention to the live chat. Over you in the research channel. How you doing, buddy? So these blue leaves are going in this big rheostat. I'm just gonna go across the caps. Get this wide open. The current there. Alright. Let's loaded. Got a little peak. I wonder what the resistance is on that. $43. 43 ohms. So that's interesting. LC circuit. Pretty much. To move this just a little. There's a lot of radiant heat right there. Alright, so I still like under 200 milliamps at 127 volts coming in, coming out, 159, 160 at almost 10 amps. What do you think? That's actually, this is acting way better than this one. I don't know if any of you guys remember this one that was in that couple of bit videos, and I had slimmed down, cut a lot off, and changed things, tuning and experimenting. But I mean, in essence, this was destroyed as a conventional transformer, three-phase transformer, but got things put pretty flat and made up that surface with some more silicon steel, so it still acts like it did before, but just, you don't see the main core on there or the shunt bars going from this end to that end on both sides. So seven. So the three-phase transformer is warmed up to 107 degrees. Still hovering around 490 degrees on the resistive load. No heat increase on the capacitors. They're just the same as air temperature. Got a beautiful sine wave coming out of that coil. 106, 107 degrees. Still almost 10 amps, a strong 9. We're, just a little meter movement on there. Not much coming into this. This is probably taking and giving back almost the whole cost. Catching the back EMF in the middle. Output coils resonated. Push that stuff back more. Yeah, I gotta do. I think I'm gonna do heating elements and a bucket of water, hot water heater elements, with a variety of them in there, so I can adjust my load to whatever I want. I had one up north, and I used it for other things, but I think I ended up giving it away. Back up to 60.2 hertz. Still 107. That's funny, the bottom half of this is 106. Top half is 107. That's interesting. 190. 93, 92 on the capacitors. It's 93 degrees in Texas right now. Probably gonna end this soon, I think. Yeah, that's funny. At the bottom of the core, it's 106. On the top of the core is 107. Heat rises. Yeah, no significant heat. The only place where there's a lot of heat is right here in these heat elements. That's our load. Yeah, so we're roughly 3 watts in. Yeah, 127 volts, 200 milliamps. Um, yeah, so we've got roughly 1600 watts coming out of this right now. I wonder how this would perform if it wasn't a freezer. Like 20 below, 30 below. Yeah, 10 amps and 160 volts, 1600 watts. Makes sense. And for argument's sake, because I'm not sure what's going on here, I've got to get my old school power meter and see if the disc is turning backwards or it's sitting still. Probably. It's probably maybe walking backwards slightly. It's got to be. So I don't think there's no real cost here. This is absolutely insane. Yeah, 107 degrees. 106 on the bottom. So the transformer is basically running at 107 degrees. And we're drawing 1600 watts. Nothing funny going on here, guys. This is all you see. Yep. This is just a small little three-phase transformer. Yeah, just a little peak on there. That's probably 20 volts. A 20 volt increase. So there was 47 ohms across 92 UF AC capacitors on 110 volt coil. And if I disconnect those capacitors, which I will do, need those. Yeah, we lose a lot. We Yeah, more than half. So the gain is more than half by having 92 UF on my 100-volt taps. You could probably find this transformer on eBay for $200-300 with shipping, maybe. I've got more. I've got some bigger ones. About 3 times the size of that. So next time I go live, that's what I'll do, is I'll have one of the bigger ones up here. Because I haven't had a chance to spend any time with them. So, I mean, this is going to be unknown. I don't know what I'm going to get out of them until we get them hooked up. My plan is to do a cascade. Start out really small and have one bit system feed another bit system, feed another bit system, maybe 3 or 4 stages. And see what I get out of it. See what I get out the other end as they build it. That's been something I've been wanting to do for a long time. Gotten lucky at the scrapyard and running into them. I haven't seen anything since. I think they're 3800 VA transformers. I've got 4 of them. And they're rather unique because 2 of them are almost this configuration, and then the other 2 are just typical step downs, all the way to, I think, 800 volt in primary taps, all the way down to I think 230 or 240. So that's a nice broad input voltage. And then the secondary side is can be 120. Let me look at them again. Yeah, can be 120 or 240 on the secondary side. So it gives you a lot of possibilities to series up a lot of coils, coil taps, because they're all individual coils. They're not taps to just one big one. And that's a rather unique thing too, having that isolation like that, because it makes it easier. And it makes it easier to resonate it too, because it gives you a lot of voltage taps potential and capacitance. It gives you a lot of options to tune the output. And this is, I don't know if you guys can hear this or not, but it's not it's squealing. Not squealing. It's got that 60 hertz buzz to it, but it's really, really vibrating. Squealing like a little piggy. Piggy, piggy. Yeah, I'm gonna have to get a better camera because I'm not happy. I mean, I think it's capable of 2K or something. I think that's where it's running right now. But I'd like to be able to have it so you get this, at least this much of a view area, and still be able to do a digital zoom and be able for you to be able to see these meters. Because I just tried it with my phone again, and it's not really clear. You can see the needle a little, but like this one here is, yes, it's not even moving. I mean, you can see the outline of it. Excuse me. For the input, and the output is even tougher to see. You can actually see a little white pinching in. I got my phone right here trying to do it, but it's at the 10 amp scale. You guys are gonna have to believe that. And I don't want to take that thing down. I got it all perfect, so I'm not gonna post any bullshit, fake crap on here. It's not the way to go. Hey, Heliac, how you doing, buddy? I didn't even know you were there. I gotta pay more attention to the live chat. I'm not accustomed to having more than 2 or 3 people in here. Hey, we got 4 now. Hello. Oh, this thing's working pretty good. I don't know if you're still there, Flint. Oh yeah, you are. Okay. Yeah, we got yeah, about just about 1,600. And this is coming in. We're bringing the grid into here, and on the coil. The coil has got 92 UF total across 100 volt tap coil on the B, and C has got 20.75 UF to resonate at 1,600 watts. So we're about 200 milliamps coming in at 127 volts. 3, 4, so let's call it 5 watts in. It seems kind of crazy, but I mean, there's nothing else going on. Here's the resistive load right here, which is hot as hell. That's attached to the final output, so we got 100 volt winding in series with 220 volt winding, resonated with a little over 20 UF. And then the 92 UF is attached to the B coil, this is disconnected. I don't know if you can see the meters move, but comes alive. This thing literally comes alive. And this control current with the capacitors is it's nothing. There's just a tiny little spark. No, hardly any current there. There's just nothing. You can barely hear it. But that's enough to maybe what we're doing is the back EMF from C is getting trapped in here for a second, and somehow it's managing to push back at the right moment back to the source. On the input, we're through 100 and 220 and another 200. Excuse me, a 120 and another 120. So that's 340 volt input. with being fed with 127 volts. So 120 volts per tap, and then so that's times 2, and then we've got one tap over here which has got 100 volts. So and all these windings are all isolated from each other, which is nice. So they're all seriesed up. So we're really reactive coming in. And we've been probably at this for about an hour now, and we're basically at 107 degrees. Just barely feel it warm. So the transformer's been running like this, drawing. Our load has been 10 amps, just a little under 10, with not much coming in. 200 mils at 127 volts, maybe 3.5 watts or something. It's crazy. Nothing else coming into here. That's just a scope that's on. I'm looking at the beautiful sine wave. This here is coming from the grid that goes underneath here. I'm actually going to pull this up so you can see that, and that's right here. So here's the white and the black. Black's going through the amp probe. I just put it underneath this cord just a little to keep it from pulling down and pulling with the alligator clips. So this is the grid coming in. That's the only thing coming in. Here's our load. $107 solid. It's not increasing, so I mean I expected it to get warm. But I really thought maybe it'd be like up in the high 118 or 20 or something like that, but maybe 130 degrees, but this is nothing. Fire'd never need a fan on it. Man, I'd love to see how this acted in a freezer. We're gonna have to find me a little freezer. Put that in there. Run that at like 30 below, 25 degree, 30 degree below. You know, because at that, I wonder how, that'd be crazy if the output increased. But you know it's gonna. You know, I mean, heat kills. So. And it's squealing like a little piggy. Capacitors are at ambient temperature. Right in the 480 range for heat. I think this is amazing. Absolutely amazing. I didn't expect to see this much gain, but we got a very high coke here, and there's no shunt bars. And I'm gonna try one, and already started the process of making them for the next size transformer, the bigger ones. I've got 2 extra cores that I cut the windings off and left the copper in the scrapyard, and they just brought the cores home because I plan on cutting them and using them for shunt bars, top and bottom. Yeah, it is amazing. How you doing, Doug? Glad you guys all made it in here. It is. This is. I've never seen a bit perform like this. I mean, I don't know if you guys can pinch the screen right now and zoom in. We're getting a little. You got a magnetic field coming off here. So with these Radio Shack, these are like brand new. I'll keep them in there. I protect them. And I still have the original boxes that these came in. I got 3 of them, but they're very accurate for AC. But I mean, they're also sensitive because I mean, I can just go near the core and sense any AC just showing up on the meter. So, but one clip being perfectly still, I mean, this is just like the needle is in between 0 and the little mark that's in between the next mark, which would be 5, and then the next mark, 500 mils, and then the next mark would be 1 amp. So we're under that, and we're right at that first little. It's like the red bar, the red needle is just on the very edge of 0. That's the only way to describe it. So that's our input, and if you pinch off the screen, this is the power feeding it, right? So I'm going to disconnect it. You can actually see just a tiny little swap. Now there's a big one because that was out of time. And that's, if your timing is wrong, then you can get a big peak on the meter. So back to 10 amps, back to 200 mils. Right around 200 mils, which is crazy. 92 UF across the 100 volt coil on coil B. So that's the only thing that we're doing there. We're not doing anything else. We're not doing anything with that power. And then 20.75 to resonate the full output using the 100 volt winding and another 120 volt winding for 240. 127 in, one's roughly right between 159 and 160 coming out at 10 amps. Just a teeny bit under 10 amps. This is nuts. Absolutely nuts. Never had a bit perform like this. And I've done one that was a little bigger than this, and I think I got, I was happy with a little over 4 times out. And that's, a friend up north has got that up in Maine. He uses it for powering his LEDs because he has a grow and shipping containers that are like literally underground. But he's all legal and everything. He just does that to get away from that's something he can manage, and he doesn't really cost him anything for heat being underground. And it's a legal grow is what he's growing, but he grows. He added another shipping container, and he's growing vegetables as well. So, like tomatoes, garden grown tomatoes on the ground. But he's been using a transformer like what we got going here, and he's got solar. I think he's got probably a little over 10,000 watts in solar. And I think when I was last up there, which was a long time now, he had got these big batteries. They're lead acid, but they were huge. Yeah. And I thought they were glass, but they're actually clear plastic. But I think they weighed like 1,000 pounds a piece. 2-volt cell that was 4 feet tall and 2 feet wide. Big, lot of lead. I think it's I don't know if they're 4. It might be 4. I think they're 4,000 amp hour cells, or maybe 5. I'm not sure. But he's got a 24 volt system that he runs with his inverter. So, but he's using to keep the power available for other things. So he's saving a lot running with and the LEDs agree with this setup. Yeah, still a lot of heat coming out. 190. All right, so now we're up to 110 degrees. Yeah, that's interesting. It's climbing a little. I wonder what the plateau will be. So 110 degrees. No heat on the caps. They're all 93, 92. Um, yeah. You know, it'd be nice if I wish YouTube would do it. Allow you to send a voice message on the live. How cool would that be? I mean, the chat's okay, but it'd really be nice to leave a voice message in the chat. Yeah. Last I checked, yeah, there's no way of doing it. I don't see anything. Everybody should ask for that. Yeah. Appreciate you guys coming out, checking this out. I just looked at the bench today. It's like, you know what? I gotta get the other things that I was working there off for a little bit. And it's like, you know what? I'm gonna just mess around, and I haven't done anything with this transformer yet. So this is the first time. Probably maybe an hour and a half ago, 2 hours ago. But this is crazy. Yeah. So I'll. I don't know if I can. Yeah, you know what I'll do is I'll take a picture of the label of this transformer, and I'm gonna size it just right, hopefully, and put that on the thumbnail of the live video once YouTube's done rendering or whatever they're doing with it. And it's a video that you can watch over and over. I'll put that on the thumbnail, or maybe do a Google Drive thing for a snapshot. Figure something out. But if you guys somebody's got a pencil handy, the pot number is actually it's the Schindler Elevator Corporation, and the part number is 222981. Yeah. It's a 865 VA transformer. It is now running at 111. So we're coming up. And we might be right around 120 by the time we're done. Then I have to let it run all under, I guess. Yeah, so load over here. Do you? Yeah, that's what this one here is one of those. Yeah. That's a great thing. Just put it right down there. Not worry about it, you know? Yes. Thank you. Thanks for doing that. Why couldn't I have put that in there? I'm an idiot. You know, I'm 3 beers deep into this project. Well, we're going to get another one. I haven't had beers in a while. And, yeah, it's been months since I even had a beer. So I've been enjoying a couple of them. Nice and cold. That's the best part. Yeah, it's still, what do we got here? It's come down a couple of degrees. It's now 91 degrees in Dolores, Texas. And it's 6:30 at night. It'll be 80 degrees at nighttime, at midnight. It's never going to cool off ever again. Yeah. So I gotta pick and choose my times out here unless I want to sweat. I got a fan blowing on me right now. Yeah, and I've got this stuff aside for a second. I got this guy here. This one, I can't wait to mess around with this one. I'll probably do this tomorrow, I hope. Yeah, 2650 VA, 208 to 480 delta. You can actually star a delta, wire delta. But that's the primary. And then the secondary is 190 volts at 8 amps and 95 at 95. Oh, at 8. So part number on this one is 222553. And it's Schindler Elevator Corporation is what it's labeled with. But I wonder who really made these for them. They resemble, I think it's Allied. Allied does this type of stuff. Yeah. Yeah, so it's going to be interesting to see. Would it be awesome to take this, to drive this one? That'd be crazy. Yeah. This one, drive this one. And then take this one and have that over here. Use this to drive that, That'd be really interesting if I can get it through 3 steps. I'm gonna have to try it. Let me get this on right. Yeah, them things aren't light. They weigh like 70, 80 pounds. Yeah. How I cut myself. Still drawing almost 10 amps. 111 degrees now. 111. Still 490 degrees in heat on that. I gotta push these power supplies back more because I want that to melt the face. The ambient temperature on the capacitors. Yeah, this is nuts. You know what I'm gonna do is I'm not gonna change any of this. I want to disconnect from the grid and get an inverter, a 12 volt pure sine wave inverter, and drive this. And see if I can't take a small portion of that 1600 watts and loop it back to charge itself. And maybe I'm going to try it directly off of these coils Well, I may run another bit over here. Take the output of this resonated coil drive. Actually, I'm going to vector through a one-to-one transformer, a microwave transformer that you took two primaries and just put the thing back together, right? And put an AC bridge on the other side of that and take that and send that to the DC bank, the cat bank, to run the inverter. And then drive another three-phase transformer into A and do the same thing. Find out if that's needed on the B coil and resonate C again, and then take the output of that and use that to run my switching power supply. And take that switching power supply to charge the DC to the capacitor bank that's needed for keeping the inverter going that will be driving it, and see what's extra. I know last year I had my inverter system running with a bit. Just I didn't even spend much time resonating it. It was the way I left it the last time. It was in the box, and I sent the output of the bit to a switching power supply to charge the 400 amp hours that I had, and I used it all week. We used it for a TV. We used it for fans. We were out of power for a while, and as long as there was at least 5 to 6 hours of inactivity or minimal usage, the thing would charge itself back up, and you could complete the cycle again for the next day and use the piss out of it. Yeah, it was 400 amp hours. Two groups of I don't know, they're about they're lithium ion, but they're about the size of a Group 27 battery. So a lot of storage. And the switching power supply is 50 amps, so it can charge itself back. I think I measured somewhere in the 40s at one moment. And I said, okay, well, let's see what happens. See if this is still going in the morning when I wake up. And it was. The fans were still going. Had two fans on there, so it was like probably, 30, 40 watts a piece for each fan because they weren't big. And the system was charging itself up. So, power nerds, yeah. We're all a bunch of power nerds. You don't have to have a little white tape in the middle of your glasses on your nose, you know. Yeah. They come in all forms. Yeah, this is amazing, guys. I mean, you write these part numbers down, and it's Schindler Elevator Corporation is the. I don't know who made them. They might have manufactured. They manufacture a lot of stuff, so I'm sure they're nicely built. What do we got for temp now? 104. Look, something's changed here. We were 110. Oh, I see what's going on here. The resonating caps come off. Ah. Here we go. So there was a little less current, and yeah, that's like 3 amps. So this clip come off, which was going to this cap that was resonating over here. So there was a little decrease, and with the decrease, the heat dropped. I mean, the heat verifying. We got going on. We got a load over here generating a lot of heat. Probably cook a hamburger on that sucker. Not much coming in over here. Barely moving the needle. We're still drawing 10 here. Almost 10. And that's it. I mean, the only other wire coming into the picture is here, coming from the scope, Antec. And that's it. Grid's coming in over here. Connects to these two wires, the white and the black, neutral and the hot. Hot's going through the amp probe. 100 volt tap on this side. 120 volt tap there, and another 120 volt tap there. So we've got 3 independently isolated coils on one pole, seriesed up in phase. A lot of reactivity, a lot of reactance going on. Really reactive. And we're getting the real power out over here. It's crazy. Yep. Scope broke. Come on. There we go. Beautiful sine wave. Yeah, we're coming back up to 110 again. So 110 degrees on the transformer. A little right around 480 degrees of heat. $92 UF on pole B. Significant difference in output. No effect on the input. That's oh shit, it's hot. You can see this needle here. Watch this needle move all the way to 10 amps. This one, it's not moving. Just a teeny little bit. About the width of the needle is all that moves. This is going through the black, coming on from the grid, right? This is real, guys. This is not bullshit. Real load. We have some wastes, but things are. We have a huge advantage with the back EMF. We're dissolving it. Yeah, 111 now. 111 degrees. Still almost 10 amps. 200 mil input at 127 volts. This is nuts. Sorry, Doug, I didn't catch you. Let's see, what is the load? The heater? Yeah, there. It's actually a. The load is a heater core from an AC unit. So, electric heating core, and it's capable of handling 220. I'm only using 1/2 of the coil. This row, this one is not being used, but this one is being used. So that's attached to this, which I think looks like, I don't know how many ohms that was. I measured it. So Yeah, so 20 UF, 20.75 UF to resonate. A 100-volt winding in series with a 120-volt winding. So it's about 220 volts with the coil. And then 92 UF is resonating coil B. And that's it. I'm not doing anything else with it. You can just barely see a small, tiny little spark. I don't know if you guys can see that. Like nothing there. But it's enough influence of creating a bounce in the silicon steel that's in the center. So I had seriesed up with this rheostat, and I think it was 47 ohms. I ended up catching a peak of I think it was either 11 or 12 volts increase on the output. So that's interesting. Down the line, to squeeze even more out of this is just to series up a rheostat in series with the capacitance between these two capacitors. Man, I can feel this thing here. It's like I don't have a shirt on, you know. It's just too hot. Got a fan blowing on me, but I can feel the radiant heat off of that thing. It's just crazy. Yep. We got the temp 112, 113 over here on this side. Yeah, 113, 110 in the middle. That's odd. And 112 down here. 113 over here. How do you think, guys? Let's see. See, connect electric. No, Doug, what I've done is I'm only resonating C with 20.75 UF through two different windings in here. So one's a 100-volt winding and the other one's 120 or 140 volt winding in series. So it looks like 220, 230 volt impedance. And on the center, on the coil B, I've got 92 UF across that coil, the 100-volt coil, doing nothing else but just that. Just adding capacitance to that coil B. And we're driving A. And there's a significant increase. I didn't add enough capacitance. I worked my way up, all the way from 1 U way up. And you know, it's some odd and even increments, but I found the peak up here, and it's like, okay, this is different. I've never seen. Usually, you do nothing with it with B, and or you can take the two of them and series them up, phase them up. But that doesn't seem to me. I tried that initially before I started recording, and I didn't like what was going on. It didn't seem like there was an advantage there at all. So that's seriesing up B and C together. In phase or out of phase. So 92 UF on coil B, 100-volt tap, and 20.75 on coil C. And we're getting almost 10 amps and hardly nothing registering on the amp probe on the black. I've never seen this with this much. 1600 watts. They got a load of 1600 watts right here. And even if these things are off by 10%, it's still a 1500 watt load. So something to think about. I apologize for that loud noise. My wife just opened up the door and threw a box at me. Yeah, it is interesting. So this is the grid coming in right here, which I've got just underneath the rag. And this is coming in here. This is the white and black right here, going through the amp probe. So this is the grid coming in. I'm just putting it underneath there to keep it from tugging on this stuff. So driving here, resonating B. We're not doing anything with it other than 92 UF across. I wish I could find another one of these transformers. That'd be awesome if one of these came in again, because I'd love to put shunt bars on this. Having another core, just get the steel, and put shunt bars on this and drive the middle and resonate the two outside ones. I know Hector doesn't like that type of, what does he call them, Doug? What he calls the shunt bars? He's got a special name for them. $115, 115 degrees on both ends. Yeah, solid 115. So this transformer is warming up. It's expected. Kind of makes sense, really. Yeah, 115 degrees. So let's see if it goes up from here. Still got 490 something. Yeah, right around 490 degrees on the heat. Ambient temperature on the caps. I don't know if can you guys hear that? I don't know if you guys can hear this or not. Let me shut the fan off for a second. I'm sure you can hear the fan. But all right, the fan is off now. See if you can hear the transformer. It's buzzing like a mother. Let me just turn the fan back on. And it's definitely squealing down this end. Buzzing pretty good. 116. Yeah, 116. This is warming up, and it's changing quicker now. Still almost 10 amps. This is interesting. So now the input Looks like it's almost touching 400 mils, maybe five. Nah, it's not. It's probably somewhere between 3 and 400 mils right now. So we're probably coming up on 9 or 10 watts in. Oh, waste. That's what it's costing us. Yeah. Solid almost 10 here. $116. Yeah, this is getting harder quicker now. So we're at 116 degrees. I'm willing to bet you this thing would really, running this thing in the freezer, that would be an incredible experiment to find out if there's an increase. What do you think, Doug? Yeah, the transverter. Yeah, I don't know. When you think in the RF world of a transverter, that's a different ball game. So myself, I guess it works, but my idea of a transverter is something totally different. Nothing related to power, RF energy more than, you know. Yeah, it's just a word. God damn right. Oh, 118. Yeah, 118. It's getting hot. And what's happening is the noticeable effect. We're still got our almost 10 amps over here, but now we're definitely on a 500 mil line. A half an amp right now at 127 volts. So that's where it shows right here. When this gets hot, your increase goes up. Your cost goes up. Yeah, still the same, 118. So even still, then you know what? It drops to zero as soon as I take the 10 amps off. When it comes back up, it's not quite making it to the 500 mil mark. It's like a needle width difference from being on it, right next to it. As this gets hotter, we can measure our losses right here. Yeah, 119 now. So I wonder where this is going to go. 119 degrees. I'm going to pour that on. Move the scope probe out of the way. I don't want it to get hot. Still 119. This is crazy, isn't it, Doug? Almost 10 amps measured here from coil C. And right now, at its worst moment, it's costing us, it's almost coming up on that 500 mil line. So it's more than 400 milliamps at 127 volts. On 19, maybe this is it. Maybe that's the peak. Yeah, I had earlier when I started this video, I had this clip lead in here which started to melt. But I had it actually seriesing up the 100-volt tap to the other 120-volt tap. And I had to take it out, put a heavier one in. Yeah, it's definitely, 119. Oh, there we go, 120. Yeah, the majority of it's 120, so. Yeah. So we're 120 degrees. Transformer is generating 120 degrees of waste. Imagine, Doug, what do you think this would do in a freezer at like 20 or 30 below? You think it'd be, I wonder if this would go to 0. Mm, 120. Nothing's changed. It's right at 120. Maybe that's where it'll stop. $490. So the heat is $490 on the load. Still drawing almost 10. Now it looks like almost 500 mils on the input at 127 volts. Still 120 degrees. Yeah, pretty solid all the way around, 120. Yeah, imagine dunking this thing in liquid nitrogen. That'd be kind of cool. Time travel. Yeah. Yeah. It's here, but it really isn't here. It's somewhere else. Different dimension. Still 120. That might be the, hopefully that's the peak. That'd be nice if that's the peak. Capacitors aren't warm near ambient temperature, whatever is in the room. Yeah, solid 120 degrees. That's no big deal. Like barely warm to the touch. Yeah, save it for Leatherman. Yeah. No, you know what I want to do is I want to just keep this just like this, and I've got a small little 500 watt pure sine 500 watt inverter. Um, so cap bank charged from the output going through a switching power supply. So I use a switching power supply, take the AC, go to the switching power supply, charge the cap bank that's going to supply the current for the inverter. Um, without phase shift, that'd be interesting to see how much I can pull off the cap bank at 12 volts or 13 volts, whatever it's going to run at, and still be able to feed itself. So run the inverter and pure sine inverter in here, and I want to fix the. I think I found the connections where I can change the frequency. So I've got to do that to it as well, because then I can change the frequency of the inverter. That would be kind of cool. But taking the 12 volts to 120 volt pure sine inverter, power this, take the output of that, go to the switcher power supply, charge the cap bank that's running the inverter, and load up the cap bank, find out what I can squeeze out of that before it wants to kill itself, find out what the overage is, see what the cope is. And if anything, take the output of this, vector through a 1-to-1, go into another transverter, and take the output of that and run that into a switching power supply to charge back at the beginning. That's a huge delay in phase shift. There's no way it could kill itself. It would be totally clueless, and there's no way it could kill itself. It's just going to run. Yeah, so I'm going to have to reorganize and get another transformer in here maybe. But initially I'm going to try taking this right straight. Actually, you know what? I'm going to vector through the 1-to-1 before I get to the switching power supply from here. Take the output of the 1-to-1 through a bridge and run that back to the cap bank that's running the inverter. That'd be an interesting system. And if I can figure out the frequency adjustment and put a potentiometer on that to steer it up or down a little, you know what? 100 hertz either way would be nice. But who knows? I might be able to get more. I don't know. I was looking at the circuit for the chip that's in there, and it looks like I think I discovered the area where it's actually controlling timing, and then actually it's using a reference crystal, which is it makes it easy because now I can alter the reference crystal frequency a little, and change things that way as well. So let's see what we got for a temperature. 122. It's getting hotter. 122. Yeah, and you know what's interesting too? Now it looks like we're the thickness of the needle on the other side of 500 mils. So the harder this gets, the worse it starts to look here. I mean, so what are we? Let's call it 600 mils, even if it might be 600 mils. It's definitely over the 500 mil mark. Yeah, it could be. I think I'm going to call that 600 mils right now. So 600 mils at 127 volts, 60 hertz. Output still 10 amps almost at 160, 159. It bounces, it's up and down a little, but it's right in the 159, 160 area. Still at 122. Yeah, so 122 degrees temperature on the transformer. Yeah, well, I think I got one of those inverters handy to grab. Pull it out anyways. Where are they? Yeah, I got that off of discount on eBay. Somebody sold it. They weren't sure if it no box, no owner's manual, no nothing. I think I paid $90 for it. I think it's a $200, $180, $190 item, so didn't pay much for it. But the first thing I did was went in there to look at to see what was going on and how it was controlled, and I got the pin outs on that chip that's in there, so you can make its increase or decrease frequency, I think, pretty easily. You still out here, Flint? Then you go to bed already, buddy. A wizard Harry, you're a wizard Harry. Hey, my name is Tim Tron, not Harry. A couple of minutes have passed. We have increase. No, that's the same. So 122 is the peak here, I think. We're still drawing almost 10 amps. And we're looking like we're drawing better than 500 mils at 127 volts right now. So not much input. I wonder if even the meter can even catch what's happening 60 times a second. That's like we're taking some and giving it back, and taking some and giving it back. I wonder. Interesting. The little compass, it rattles. There's a lot going on in here. Definitely a lot going on in here. I'm 22. Yeah, so I guess 122 degrees is what we're generating on a 90, almost 10 amp load. That's, I think this is unbelievable. Unbelievable. Yeah, all right. Sounds good, Doug. Yeah, I've looked at a lot of different inverters, and they all seem to try to avoid infringement of some sort. So there's like 3 or 4 different schemes they use for frequency control, and some of the inverters use a oh, you're welcome, buddy. Yeah, thanks for coming and hanging out and wasting your time with me. Yeah, I hardly ever go live, but you know what? It's like, you know what? Doug went live yesterday, so I just had to do it. Yeah. And then I figured I was going to do it with this. I had this idea this one. I was like, you know what? I haven't messed with this yet. Let's do it live. Like Dave Riley said. You guys remember that? Dave Riley? Fuck it, we'll do it live. You know? So that's what we did. And look at what we got. For the cost of a little over a half an amp at 127 volts, we're getting 160 something volts, 159, 160 volts out, resonated with 20.75 UF into a resistive load at almost 10 amps. That's a considerable amount of energy. Yeah, this is definitely 122. It's capped out right there. We're not increasing at all. So let's see what happens. So we'll do this for a few more minutes, and if it don't increase, then that's not bad. There's so much heat coming off of this. I could barely feel anything radiant around here, but this is crazy. Let's see. There's more stuff growing. Yeah, somebody's probably already done this. Hector's done it. You got Thane Hines. A lot of people. There's a lot of people on YouTube right now that have got different versions of this. Doug, how many hours have you put in this stuff? And actually, I'm taking the quick and dirty way out. I'm just trying to get, well, not come from a scrapyard, but essentially it's an off-the-shelf item, which I always love the idea. It's already made. Let's just violate that thing somehow. an unconventional way, right? Um, I mean, that's just a run-of-the-mill, nothing fancy, three-phase transformer. And look at what we're doing with no shunt bars. Running it like Hector says, it's a transverter. I just like to say a single-ended BiTT. It's just single-ended, you know. But whatever. Yeah, 122. So 122 degrees. That's not bad. That's all we have to worry about. Oh yeah, most definitely. This will be on there. You guys can watch this, and I might I don't even know how long when I started, but I know it's a long video now. What do we got here? I started at 4 minutes after 5, and it's 7:20 now. So I might break this up into 2 or 3 videos, or hell, I might just keep it. I'm just gonna leave it alone because it's. Yeah, I just leave it alone. It'll be there for anybody that wants to relive the moment. All right, so just for a general recap, 127 volts coming in at roughly 600 milliamps at 122 degree temperature on the three-phase transformer. We've got almost a 10 amp load, and we're using a heat bank, coil bank that's used for an air conditioner for heat. And we're only using one side of it. So we're drawing almost 10 amps. We're resonating with 92 UF in the 100 volt coil. On coil B, coil C is resonated with 20.75 UF to the tune of 160 volts and at almost a 10 amp load. 400 milliamps in at 127 volts. That's crazy. I didn't expect that. So, yeah, I think there's a lot of people that have spent a lot of time with the bit. I think some really never really grasped how it functions. But I know Doug has done a lot of work with it too. Still 122. So that's the peak. The heat. Not bad. All right, guys, I'm going to wrap this up. I appreciate everybody that's been hanging out. Doug, Heliac, Debut. What else did we have on here? $122. So I'd say that's it. That's the peak for heat. This is unbelievable. All right, guys. Feel free to download this video for personal use. Don't re-upload it anywhere. Definitely embed it if you want. That'll help the channel. If you haven't subscribed, which obviously you guys have subscribed because you're chatting. But any future viewers, you're going to have to subscribe if you want to leave it. Actually, you can't chat. That's just DVR, I think, like at that point. All right. See you guys soon. Thanks for visiting. Thanks for hanging out. Peace, man. Yes, sir. You too. Thank you. Thanks, Doug. Thanks, Flint.